Good day, class. Welcome to our Science 10 class. I am Mrs. Victorina F. Oliveros, your Science 10 teacher. We are now on Quarter 2, Module 1, Week 1, and our topic is all about the different forms of electromagnetic waves. Our learning competency for today is to compare the relative wavelengths of the different forms of electromagnetic waves. So, class, what are our objectives for today? My handsome and beautiful students, I am asking you to please read with me our objectives. Objective number 1. Compare the relative frequencies of the different forms of electromagnetic waves. And objective number 2, identify the relationship among wavelength, frequency, and energy of an electromagnetic wave. My dear students, can you still recall the different concepts of electromagnetic waves you've learned in grade 7? Now, let us try to find out how much of these concepts are retained in your memory by answering our activity. Our activity is named 4 picks, 1 word. You are going to guess the word represented by the 4 pictures in each frame. The jumbled letters is your clue to the correct answer. Are you ready? In 5, 4, 3, 2, 1. I am inviting everyone in this class to please prepare your paper and pen. Try to observe the 4 pictures presented and guess the word by trying to arrange the jumbled letters. So, what do you think is our first word? If your answer is wave, you are correct. You have learned in grade 7 that a wave can be described as a disturbance that travels through a medium from one location to another location. It has the following parts. Amplitude. It is the maximum amount of displacement of a particle on the medium from its rest position. Crest. It is the upper part of the wave. Trough. The lowest part of the wave. And wavelength. It is the distance between crest or between trough. Our second word. If your answer is wavelength, you are correct. Wavelength is the distance between crest or between trough, or it is the distance between 2 successive identical parts of a wave. Our third word. If your answer is frequency, you are correct. Frequency refers to the number of waves produced in 1 second. The blue wave represents a high-frequency wave, while the red wave represents a low-frequency wave. And our last and final word. Your answer is energy. You are correct. Electromagnetic waves carries energy. An electromagnetic wave with low amplitude has low energy, and an electromagnetic wave with high amplitude has high energy. Energy is also directly proportional to its frequency. The higher the frequency, the higher is its energy. At this time, my dear students, we're going to play a game show. I am going to play a roulette with your names on it. If you are chosen, you will be the one to answer my question. And if you answer my question correctly, you will be given 5 points score. So class, are you ready with our first question? Okay, number 1. These are waves that are created as a result of vibrations between an electric field and magnetic field. A. Electromagnetic wave. B. Electromagnetic spectrum. C. Microwave. D. Radio wave. Who will be our lucky student to answer this question? Watch this. Erlyn Joy, you're the lucky one, so what's your answer? Very good! The correct answer is electromagnetic wave. Electromagnetic waves are created as a result of vibrations between an electric field and magnetic field. Are you ready with question number 2? Okay, number 2. Electromagnetic waves are produced by blank. A. Any disturbance. B. Current. C. Vibrating charge. D. Voltage source. Who will be the lucky one to answer this question? Let's find out. Congratulations, Mai! You are the lucky one. So, what's your answer to question number 2? Letter C, vibrating charge, is correct. Electromagnetic wave is a wave that is created as a result of vibrations between an electric field and magnetic field, hence known as electromagnetic wave. A changing magnetic field is therefore produced around a vibrating charge. Ready for question number 3. Which 2 colors of light lie at the beginning and end of the visible spectrum? Letter A, red and violet. Letter B, red and yellow. Letter C, yellow and violet. And letter D, yellow and green. And who will be our lucky student to answer this question? Let's find out. Congratulations, Imelda! It's your turn. Excellent, Imelda. The correct answer is red and violet. Letter A. These 2 colors lie at the opposite end of the visible spectrum. And let us all be ready for our last question. What happens to the frequency of electromagnetic wave if its wavelength increases? Letter A, it decreases. Letter B, it doubles. Letter C, it increases as well. And letter D, it remains the same. Let's find out who will be our lucky student to answer this question. Congratulations, Charmaine! So, what's your answer? Very good! The correct answer is letter A. It decreases. As you can see in this part of the spectrum, it has shorter wavelength but higher frequency. After having some ideas about electromagnetic waves, we will get to know these waves better by watching the short video clip. After which, on your activity notebook, list the different types of electromagnetic waves and their description.
Types of electromagnetic waves. The electromagnetic spectrum encompasses all wave frequencies, including radio, visible light, and X-rays. All M waves are made up of photons that travel through space until they interact with matter. Some waves are absorbed, and others are reflected. Though the science generally classify M waves into 7 basic types. All are manifestations of the same phenomenon. Radio waves, instant communication. Radio waves are the lowest frequency waves in the M spectrum. Radio waves can be used to carry other signals to receivers that subsequently translate these signals into usable information. Many objects, both natural and man-made, emit radio waves. Anything that emits heat emits radiation across the entire spectrum, but in different amounts. Stars, planets and other cosmic bodies emit radio waves. Radio and television stations and cell phone companies all produce radio waves that carry signals to be received by the antennae in your television, radio, or cell phone. Microwaves, data and heat. Microwaves are the second lowest frequency waves in the M spectrum. Whereas radio waves can be up to miles in length, microwaves measure from a few centimeters up to a foot. Due to their higher frequency, microwaves can penetrate obstacles that interfere with radio waves, such as clouds, smoke and rain. Microwaves carry radar, landline phone calls, and computer data transmissions, as well as cook your dinner. Microwave are remnants of the Big Bang, radiate from all directions throughout the universe. Infrared waves, invisible heat. Infrared waves are in the lower middle range of frequencies in the M spectrum, between microwaves and visible light. The size of infrared waves ranges from a few millimeters down to microscopic lengths. The longer wavelength infrared waves produce heat and include radiation emitted by fire, the sun and other heat-producing objects. Shorter wavelength infrared rays do not produce much heat and are used in remote controls and imaging technologies. Visible light rays. Visible light waves lets you to see the world around you. The different frequencies of visible light are experienced by people as the colors of the rainbow. The frequencies move from the lower wavelengths, detected as reds, up to the higher visible wavelengths, detected as violet hues. The most noticeable natural source of visible light is, of course, the sun. Objects are perceived as different colors, based on which wavelengths of light an object absorbs, and which it reflects. Ultraviolet waves, energetic light. Ultraviolet waves have even shorter wavelengths than visible light. UV waves are the cause of sunburn, and can cause cancer in living organisms. High-temperature processes emit UV rays. These can be detected throughout the universe, from every star in the sky. Detecting UV waves assists astronomers, for example, in learning about the structure of galaxies. X-rays, penetrating radiation. X-rays are extremely high-energy waves, with wavelengths between 0.03 and 3 nanometers. Not much longer than an atom. X-rays are emitted by sources producing very high temperatures, like the sun's corona, which is much hotter than the surface of the sun. Natural sources of X-rays include enormously energetic cosmic phenomena, such as pulsars, supernovae, and black holes. X-rays are commonly used in imaging technology to view bone structures within the body. Gamma rays, nuclear energy. Gamma waves are the highest frequency M waves, and are emitted by only the most energetic cosmic objects, such pulsars, neutron stars, supernova, and black holes. Terrestrial sources include lightning, nuclear explosions, and radioactive decay. Gamma wave wavelengths are measured on the subatomic level, and can actually pass through the empty space within an atom. Gamma rays can destroy living cells. Fortunately, the Earth's atmosphere absorbs any gamma rays that reach the planet.
Thank you, class, for watching the video seriously and attentively. You will be given 15 minutes to answer the activity on your activity notebook. Work quietly and honestly. Your 15 minutes starts now. Okay, class, time is up. Please pass your activity notebook. After knowing the different types of electromagnetic waves, your next activity is to study and analyze the given pictures carefully. Then you're going to complete the given table. The first column is the category, whether it's the highest or the lowest. The second column is wavelength, followed by frequency and energy. So in this activity, based on the given picture, you're going to identify the electromagnetic waves with the highest and lowest wavelength, frequency, and energy. Okay, we have here our picture number 1. In picture number 1, you will be able to see the different wavelengths of the different electromagnetic waves in the electromagnetic spectrum. We are aware that wavelength is the distance between crest or between trough. So, which of this electromagnetic wave has the longest wavelength? Which of this has the shortest wavelength? Answer the question. So, here's our picture number 2. Notice the different wavelengths of the different electromagnetic waves. We are aware that frequency is the number of waves that pass a fixed point in a given period of time. So which do you think has the highest frequency? The one with the longer wavelength or the one with a shorter wavelength? Okay, so answer this question. Which do you think has the highest frequency? And which do you think has the lowest frequency? Try to observe our last picture. At the bottom part of the picture, you will be able to see numbers. So, based on these numbers, which do you think has the highest energy and the lowest energy? Is it the radio wave or the gamma ray? Answer the question. So class, after our activity on picture analysis, our next activity is increasing or decreasing. You're going to identify what happens to the wavelength, frequency, and energy of the electromagnetic waves following the direction of the arrows. You may answer increasing or decreasing inside the arrows. My dear students, this is the arrangement of our electromagnetic waves: radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. On the first column, we have here wavelength. What do you think is the arrangement of electromagnetic waves in terms of wavelength, increasing or decreasing? What's your answer? Decreasing. You are correct. Very good. Radio wave has the longest wavelength and gamma ray has the shortest wavelength. So class, on the third column, it is about frequency. So I am asking you, what can you say about the frequency of electromagnetic waves from the radio wave to the gamma ray? Is it increasing or decreasing? What's your answer? Increasing. Correct. Very good. Gamma wave has the highest frequency while radio wave has the lowest frequency. So it is increasing from radio wave to gamma ray. And finally, on the last column, we have energy. What can you say about the energy from radio wave to gamma ray? What's your answer? Increasing. Very good. Energy increases from radio wave to gamma ray. That means radio wave has the least energy while gamma ray has the highest energy. So class, try to observe under wavelength it is decreasing. Under frequency, it is increasing. So what can we infer on the relationship between wavelength and frequency? Very good. It is inversely proportional. How about between frequency and energy? Take note that electromagnetic wave increases from radio wave to gamma ray in terms of frequency, and it is also increases in terms of energy. So, what can you infer on the relationship between frequency and energy? Very good, directly proportional. They are directly proportional because as the frequency increases, energy also increases. At this point, class, we are going to activate your musical intelligence. You are going to listen carefully and sing the song on electromagnetic spectrum song. You have to take note of the different practical applications of electromagnetic waves presented in the lyrics of the song.
Electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. From the TV station to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin kill bacteria and viruses. Used to detect forgery, that is ultraviolet. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. See your broken bones and your hidden bombs, that is the work of X-rays. Kill cancer cells and sterilize dangerous gamma rays, do that. Now we have completed the electromagnetic spectrum. If you still do not understand, then play the song again. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays, radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays.
Thank you for singing the song well. I feel that you really enjoy it. Now, we're going to summarize the important concepts we discussed for today. Read the statements carefully and pick out the word that will make the statement correct. Okay, class, shall we read your answers? The electromagnetic spectrum is the arrangement of electromagnetic waves, which are waves that are created with changing electric field and magnetic field. Electromagnetic waves travel on vacuum at a constant speed of 3 × 10⁻⁸ meters per second. The electromagnetic spectrum is arranged in a manner of decreasing wavelength, increasing frequency, and increasing energy. Radio wave has the longest wavelength, lowest frequency, and lowest energy among all electromagnetic waves. Visible light is the only electromagnetic wave that can be seen by our naked eye, whereas red has the longest wavelength and violet has the greatest frequency. On the other hand, gamma ray has the shortest wavelength and highest frequency, which carries the highest energy among all electromagnetic waves. Therefore, radio wave has the lowest ionizing radiation and gamma ray has the highest ionizing radiation. Before we're going to end our lesson for today, I want to find out whether you learned something from today's discussion. So class, get your quiz notebook and answer the following questions. My dear students, time is up. Pass your quiz notebook. I hope you enjoy and learn something from our lesson on electromagnetic waves today. Thank you, class, for your participation, and God may bless us all.